Hi guys, I'm Yugma Patel and today I will explain all the Google Colab files of decision tree assignment. So first we will start with GBM from scratch. So here we are first importing pandas, then we are loading the dataset, then we are trying to display few rows, first few rows of our dataset. Then we will fill the missing values, then we'll start the encoding part, then splitting the data, standardizing the features. Then we will start the prediction. We will initialize the predictions with the mean of the target. Then we will do prediction of residuals for training and testing. And then after that we will update our predictions. Then we will start with boosting rounds. So first there are 100 number of boosting rounds. Then gradient boosting iterations. Then we will store the train tree and predict it. Now we will start with log of our dataset. Then lastly we will have final evaluation. After that we will track the losses losses of training, and then we'll plot a graph of it. Now we will move on to random forest uh, Google Colab file. So first we will start with importing libraries, then loading our dataset. Our dataset for this is Vine dataset. Then we will start our decision tree implementation. So this is the implementation. We will make different functions, classes. Uh, this is the code. Then we will define a random forest class, and at last we will train and evaluate the random forest. After that, we will do prediction of it. Now I will start ADF boost algorithm. So here, as usual, we have to import various libraries. Then again, we have to make different functions and classes accordingly. And then we will generate random binary classification problem. Then initialize the classifier predictions. Then at last, we will visualize the decision boundary. Now we will move on to decision tree. So in this, firstly, we have to import our libraries. Then we have to make different class like node class in that function. Then decision tree classifier in that various functions. After that, we will calculate parent gene impurity. We'll try all different features, possible thresholds. Then we will calculate the gene impurity for children for weighted average gene impurity. We will also calculate that, and we will update the best split, and these are different functions which we used to perform this task. After that we'll generate a random binary classification problem, then splitting the data. Then we will create entry in the decision tree. Then we will make predictions. Then we will visualize the decision tree structure. After that we will visualize the decision boundary. Here we will plot a graph of it. After that we will move on to GBM classifier techniques. In this technique, first we have to install catboost library, then we will import various libraries. Here also we are taking the Vine dataset, Iris dataset. Then we will make a function to evaluate and print accuracy, then XGBoost, and then we'll do catboost light GBM. So this is all light GBM, then we will perform random forest, then ADA boost, and lastly decision tree. After that, I'm starting GBM ranking techniques. Here first we have to install Kaggle Hub, then import it. After that, we will download the dataset using Kaggle. Here we have students performance dataset. Then we'll import it, load the dataset. Now we'll print a few rows of the dataset, encode it, split the data into training and testing stats. We will apply gradient boosting. After that, we'll train the model, we'll predict the values, and then we'll evaluate the model. And lastly, we will visualize different features and its importance. Now we will move on to GBM regression techniques. This is last one. And for this, we have to install the various libraries such as CatBoost, LightGBM, XGBoost. Then we will import all the libraries. We will load the dataset. Here we are taking California housing dataset. We'll split it, standardize the features. We'll make a function to evaluate and print MSE, and then we will move on to CatBoost and LightGBM. So these were all Google Colab files of decision tree assignment, and I have performed it in front of you guys. So thank you.